The importance of light in the dark depths of the ocean. The ocean is vast, mysterious, and largely unexplored, especially the deep sea regions that extend from around 200 meters to the ocean floor, thousands of meters below the surface. These dark depths, devoid of sunlight, are home to a diverse range of organisms that rely on unique adaptations for survival. Among the most intriguing of these adaptations is the ability of many creatures to produce light. In the absence of sunlight, light becomes a vital tool for communication, predation, camouflage, and mating. This story explores the fascinating importance of light in the dark depths of the ocean, and how bioluminescence plays a crucial role in the lives of deep-sea organisms. The absence of sunlight in the deep sea. As sunlight penetrates the ocean, it begins to fade at around 200 meters, and by the time you reach the deeper regions, beyond 1,000 meters, the ocean is pitch black. In these depths, known as the midnight zone or aphotic zone, there is no natural sunlight, and temperatures hover around freezing. The immense pressure and lack of light make it one of the most hostile environments on Earth. Despite these extreme conditions, life thrives in the deep sea. Organisms here have evolved over millions of years to survive the lack of light through various methods. One of the most remarkable of these is bioluminescence, the production and emission of light by living organisms. Bioluminescence, light produced by living organisms. Bioluminescence is the ability of certain organisms to produce their own light through a chemical reaction within their bodies. This process involves luciferin, a molecule that emits light, and luciferase, an enzyme that triggers the reaction. When luciferin interacts with oxygen in the presence of luciferase, light is produced as a byproduct, typically in the blue or green spectrum. In the deep sea, where light is absent, bioluminescence serves a variety of critical functions for survival. Functions of bioluminescence in the deep sea. 1. Attracting prey. Many deep-sea predators, such as anglerfish, have evolved specialized bioluminescent lures that attract prey. These glowing lures are often situated on long, flexible stalks that dangle in the water, swaying like bait. The light attracts smaller fish and plankton, which are drawn toward the glow, only to be captured by the predator. In this way, bioluminescence helps predators in the dark depths find food in an environment where sight alone is ineffective. 2. Camouflage and counter-illumination. Some creatures like squid and cuttlefish use bioluminescence as a form of camouflage. By matching the light levels and color of their surroundings, these animals can blend into the faint light that comes from above, effectively hiding from predators. This adaptation is known as counter-illumination. The light emitted by their bodies helps to obscure their silhouette against the faint light from above, making them nearly invisible to predators hunting from below. 3. Communication and mating. In the dark depths, where visual communication is limited, many species of fish and invertebrates use bioluminescence to communicate with one another. Male fireflies, for example, use light to attract mates in a similar way to how certain fish species use their glow to signal potential mates. These light patterns may serve as a signal of readiness to mate or to attract attention from the opposite sex. In some species, males and females synchronize their light patterns to facilitate successful mating, which is particularly important in environments where visibility is minimal or forerun. Defending against predators, bioluminescence also serves as a defense mechanism for many organisms. Some species of squid and fish have evolved the ability to release a burst of light when threatened, temporarily blinding or confusing their predator. This moment of distraction allows the prey to escape, effectively evading capture. Another defense strategy involves bioluminescent ink, released by some cephalopods, such as squids, which can create a glowing cloud of light in the water. The flash of light can temporarily obscure the predator's view, allowing the squid to escape into the darkness. Examples of deep-sea bioluminescent creatures. Anglerfish. Perhaps the most famous bioluminescent predator, the anglerfish has a glowing lure on top of its head that it uses to attract prey. The fish uses its luminescent bait to lure smaller fish and shrimp within reach. Lanternfish. These small fish are one of the most abundant bioluminescent creatures in the deep sea. Their bodies contain light-producing organs called photophores, which they use to communicate with each other and camouflage from predators, jellyfish. Some species of jellyfish, like the Aquaria victoria, produce light through bioluminescence. Their glowing bodies help them evade predators and attract mates. Cuttlefish and squid, these cephalopods use their ability to emit light for both camouflage and communication. Their sophisticated control over bioluminescence allows them to blend in with their environment or send signals to others. Firefly squid, a species that lives in the waters off Japan. Firefly squid have bioluminescent organs all over their bodies. During their spawning season, they light up the ocean, creating an incredible natural light display. The role of bioluminescence in ecosystem balance. Bioluminescence plays a crucial role in the balance of deep-sea ecosystems. It facilitates the complex web of relationships between predators, prey, and other organisms. The availability of light in the depths allows for a highly specialized form of predation and camouflage, which helps maintain the health of the food chain in these dark regions. Furthermore, bioluminescence has a significant role in the distribution of energy through the deep-sea food webs. For example, the glowing light produced by plankton may be the key to attracting larger predators, allowing larger predators to flow out of the trophic levels of the ecosystem. The future of bioluminescence research. As scientists continue to explore the deep sea, our understanding of bioluminescence and its role in these ecosystems grows. The potential applications of bioluminescence are vast, including its use in medical research, engines exhausting processes, environmental monitoring, and detecting pollutants. And biotechnologies researchers are also investigating how bioluminescent organisms might inspire new technologies, such as energy-efficient lighting systems, sustainable materials, and advanced medical imaging techniques. Conclusion. The importance of light in the dark depths of the ocean cannot be overstated. Bioluminescence has allowed countless deep-sea organisms to thrive in an environment where sunlight is absent. From aiding in predation and communication to providing a means of defense, light is a critical component in the survival strategies of many marine species. As we continue to delve deeper into the mysteries of the ocean, bioluminescence remains one of nature's most fascinating and essential phenomena.